Well, ladies and gentlemen, developers around the world, welcome to Data Talks on the Rocks. I am delighted today to be with my guest, Kishore Gopalakrishna, who joins me from StarTree, where he is the founder, CEO, and creator of the wildly popular database Apache Pinot. Kishore, thanks for joining Data Talks on the Rocks.
Thank you, Mike, and it's my pleasure to be on the podcast.
I want to start just talking about the past and present of the Apache Pinot project, how it came to be. I've listened to a number of your interviews over the years talking about your past at LinkedIn. I know you were a senior staff engineer at LinkedIn. Previously, you worked at Yahoo, where a number of innovations in distributed systems came out of. I guess, rather than go back and retell that origin story of Pinot that began at LinkedIn, I'd like to refer to it, but I'd really like to focus on, I think, the question that I ask anyone who's created a net new technology innovation, which is, why did you choose to build a new database? I'll start with a quote I heard from another database creator who said, every database is an overnight success after 7 years. Common wisdom says it takes about 7 years to get a database to a level of maturity. Maybe just tell our audience and our listeners a little bit about what was the real motivation back in a decade ago now to create Pinot, and what were the pain points that you were addressing that were not addressed by other technologies at the time? So I'll start with that.
Yeah, no, I think that's a great question, Mike. And I think one of the things that I probably mentioned in few interviews, but I think the reality is I actually didn't want to build a database. I was because this was not the first database that I built. I had built multiple systems before this. And I also built Espresso, which is like a key value NoSQL distributed system. And I know I mean, 7 years is probably an understatement. I think it takes a lot longer than that. And especially the last 10%, you can get to 0 to 90 very quickly. But I think beyond that is what takes a lot of years. So for me, when I was actually got into the Pinot project, I mean, there was already a solution which was kind of built on Elasticsearch. So for me, I was like, it was more about like, hey, let's take this and then take it to the next level. So I was hesitant in terms of building a new system. But then I think the challenge was always, as you get deeper and deeper, you kind of feel that, hey, you can't really make this work. You can't really take it very, very far. And I think that's when you go to the fundamentals and say like, hey, how are these systems actually built from ground up? And in this case, I'm referring to Elasticsearch, which was kind of the original solution. And that's where we had to take a step back and then see like, hey, I mean, I can probably make this work a little bit, push it here and there, put some hacks around it, but then I can't really go very far. I think that was one of the things.
Well, to get specific, so obviously both Yahoo and LinkedIn, place where a lot of really powerful innovations were created. Obviously, Hadoop came out of Yahoo.
Yep.
Kafka came out of LinkedIn. The engineer who actually initially created Apache Druid was also a LinkedIn engineer at one time. Eric Cheddar, who's now at Imply. And one question I would have is, and of course, ClickHouse was probably quite early, but ClickHouse, was built, did exist at that time. There was Vertica. There were some open source projects, out there. My question would be, when you started looking at creating Apache Pinot inside of LinkedIn, what didn't exist in those other tools, whether it be Apache Druid, whether it be early versions of ClickHouse? I don't know if it was open source at that point. What was missing in particular from those other architectures that led you and some of your colleagues to say let's start something new?
Yeah, I think that's a great question. I think Druid was definitely something that was available at that point. I think the main biggest thing that we wanted to do at that point, and if you look at the whole real-time system that was coming up, and then Kafka being originated there, we wanted to take a different idea in different approach in terms of ingesting data. And if you go
Hmm.
back and look at Druid, they had this middle, I forgot what it's called,
Middle
like
manager.
middle manager. Yes, they had really creative names, and then it was pulling data from Kafka and then writing it to their other servers. And I think that for me, given the importance of real time and how quickly they wanted to actually reflect this to the dashboards, either be it in the products that we are building, was
Hmm.
always an going to be in kind of an impedance mismatch, right? Because we really
Hmm.
wanted, like, as soon as something shows up in Kafka, you should be able to query it immediately. There shouldn't be any micro batching, or there should also be ability to, in terms of, get the best performance. The partitioning concepts and all those things actually matter a lot. So being very
Hmm.
tightly coupled with these new kinds of systems, which is push, not the push-based systems, but kind of pull. And if we can
Hmm.
embed those consumers directly within Pinot, then we can actually do a lot more than what the traditional systems can actually do. So that was the first thing, was like, I want zero latency between the source to being able to provide insights, right? So that was the first part.
Hmm.
And then the second, sorry, go ahead if you.
No, no, please go ahead. Yes.
Yeah, so then the second part is where Druid, while architecturally it was the same, I wanted to get into the how part of it, right? I think that is where the optimizations came into picture, which is, hey, how can we do less work on a given query? And one of the things that we noticed is, even though these are all time series data, each each data segment can actually have a very different data profile. So
Hmm.
if you actually dig deep into Pinot, the query plan is actually different for every segment. It's not that,
Hmm.
oh, we just look at the SQL layer and then at a very logical level, we are actually coming up with the plan. So we went deep into optimizing physical, because if you just try to optimize at logical level, which most databases do, it was not good enough, because we are not really looking for like second level latency. Our goal was like, a P99 should be less than 100 milliseconds. Like Jeff Wiener would actually call if who viewed my profile didn't load within 100 milliseconds. So we kind of
Hmm.
not looking at, hey, here is the dashboard. Let's make that faster, right? That was,
Hmm.
we were not going after building faster dashboards. We were like really bridging. There is concept of OLTP, like, the
Hmm.
workloads and the kind of expectations that people have, but for OLAP functionality. So
Hmm.
our real thesis was like OLAP at OLTP scale. So that was
Hmm.
what we actually went. And then for me, it was always about having the strong fundamental foundation so that I can go very far. It's like,
Hmm.
yes, we may not choose to solve all the problems at once, but how strong is our core foundations, which is really about optimizing to the physical plan, making sure that we don't do even a single, if a road doesn't need to be scanned, it shouldn't be scanned. Like,
Hmm.
we index as the first class citizen. It's not the other way around where you just do a brute force scan. So a lot of these fundamentals were very important for us, and we saw the problems. And I could clearly see that taking any of these existing wouldn't let us go to the scale that we really wanted. And if you look at today, LinkedIn is serving 650,000 queries per second
Off of their
of,
internal
of,
Pinot
of the
cluster.
Pinot. So this was
Right.
like, who viewed my profile was started with 1,000 queries per second, right? And
Right.
that's
Right.
really where I wanted it to get to, is like truly OLTP scale, right? And this is generally, when you think of like 500,000 to 1 million queries per second, that's all OLTP. You just key value stores, you just keep looking up. And then I really wanted to push it to the fact that an OLAP engine can actually do this, and that's very happy that we are there, and I'm looking forward to reaching the 1 million queries per
The
second.
million mark. Well,
Yeah,
who knows? The thing about open source is there might be a
there
company
might be
out
an,
there
yeah.
that's using StarTree and Pinot at that scale. I think zooming out a little bit, and then I'm going to zoom back in and talk a little bit about
Hmm.
index, support that's very unique about StarTree. In fact, the
Hmm.
origin of your name is
Yep.
the StarTree index. But
Yes.
zooming out a bit and talking about, okay, I've heard you say there's really three things that Pinot looked to differentiate on. The first being data freshness,
Hmm.
that tight integration with Kafka and making data available kind of as soon as it hits. The
Yep.
moment an event occurs, you want the analytical applications to be aware of that data, not to have
Hmm.
this kind of high latency between when events happen and when the database system can be queried. So that
Hmm.
OLTP scale and frankly OLTP maybe latency as
Yes.
well.
Hmm.
Second is I heard you just talk about another form of latency is just query latency, right? Getting that P99 to a place where under 100 milliseconds. I think I've
Hmm.
heard quotes for different systems, but it feels like in general Pinot tries to target um, around sub 100 milliseconds
Hmm.
per query, which is again
Yep.
a level of latency that certainly you don't see with more traditional cloud data
Hmm.
warehouses like BigQuery, Snowflake,
Absolutely.
Redshift.
Yeah. Yeah.
Um, and then maybe the third one, which I'll just throw out there, and then I'm going to zoom out and ask
Hmm.
you about use cases. The third one I've heard you talk about before is concurrency.
Yeah.
Um, and certainly user-facing analytics, embedded analytics. When you have something
Hmm.
that's facing the world, you can get a million queries a second
Yes.
because
Hmm.
uh, there's a lot of users out there on the planet Earth
Yeah.
that are interacting with these these platforms that are running Pinot in the background. I think the given that architectural profile, latency, low latencies, high concurrency,
Freshness.
freshness of data. Given that architecture, what what maybe if you could name names, that's great. But what are some of the companies or the use cases that tend to be attracted to an engine like Pinot, given what it can do? What are some of the concrete things, whether in fintech or crypto or retail or social media? Love to just hear a couple of stories where this was beyond LinkedIn, where this was really the right tool for the job.
Hmm. I mean, I would definitely talked about a lot, but I mean, start with Uber, right? I mean, it's just that was the next biggest place where Pinot became widely popular. And it's just amazing the kind of use cases that they have been using. I mean, Uber Eats is one of the things. I think you talked about the concurrency part, right? And again, this was one of the vision for us is like truly democratize data. And I think this
Hmm.
data democratization has been talked a lot, but it's always limits to people within the company, right? And then
Hmm.
our goal was always like, hey, take it beyond the company to your users. And Uber Eats did that fantastic, right? And in terms of if you look at Uber Eats, you see the time, and then that time is not as stale time that was, hey, this is what the restaurant took yesterday to serve the order, but it's like it's querying the live orders in the last 30 minutes and how long is it actually taking. So that's a great example of live query being
Hmm.
run whenever you look at an application. Same thing with
Yes.
Stripe. Think about all the merchants of Stripe, right? Like and hundreds of millions of merchants. They're looking at their dashboard and like live analytics, and then they're getting these numbers from Pinot behind the scenes. Walmart, you mentioned about retail. Every order that you place on Walmart.com actually gets into Pinot, and you can think of the state transitions like, okay, the order was placed, it was in the inventory, it was shipped. The entire fulfillment tracking is done behind the scenes with Pinot. So I think the key that we found was what we saw in LinkedIn and then Uber. Pretty much every company went through that transition 5 years later because
Hmm.
they had the Kafka adoption and they had all these some sort of a system that either it is Kafka or Red Panda or Pulsar or any of these things where they say like, hey, now I have access to these events live. But then always the first approach most people do is like use the system more as like an ETL system where they take the data from Kafka and then just
Hmm.
dump it into data lake. And then
Hmm.
it's a fine thing to do first because that's one of the best in the uses of Kafka and widely used as well. But then suddenly you realize, wait a minute, I have this very, very fast system, and then I'm taking that and putting it into a slow system. And I'm like,
Right.
my value of this data is completely lost. And the reason I started with this architectural shift is to be able to capitalize on this data. And that's where Pinot comes in. And then people start doing this like 2, 3 years into their journey after adopting something like some streaming system like Kafka. Then they
Mm-hmm.
start thinking, okay, now can I actually get the value out of this system immediately, right? I mean, we have some of the use cases in like Citibank, for example. They went from 10 seconds, 10 minutes to actually 10 seconds in terms of the freshness that they wanted. Huge value that they were able to get, right? So there is this amazing potential in data in the first few seconds or even first few
Right.
minutes. And if you are able to um, leverage that and see the value, then it's endless. Like you will start coming up with like so many applications that you had not thought
Mm-hmm.
about before, right? I mean, Uber, for example, had this Uber Freight, which is a very interesting application, which is they're just tracking the progress of their drivers, the truck drivers,
Mm-hmm.
and they kind of gamified that and then provide real-time insights to them on like, hey, this is the route you should take, this is you shouldn't be spending time here or whatever it is. They saw like huge improvement in business in terms of being on time, and then they saved millions of dollars. And so I think it's just one of those things where most people don't realize the possibility
Mm-hmm.
of having a technology like Pinot. And
It's
once they
truly real
see
time.
truly real time and the kind of impact they can have on their users, and once they see that, you can't unsee that. That's when it starts blowing up and like, hey, I want this in every
More
application,
and
that
more.
more and more of it, right? That's kind of how LinkedIn has come to this scale where we just started off with who viewed my profile, and then like, every team wants it, and every product,
Yes.
every vertical is like any number you see on LinkedIn is now being powered by Pinot. Sorry, that was a long answer, but that's kind of how.
Real-time data talk about how there's essentially an exponential decay, right, that
Yeah.
occurs with data. So knowing about something 10 minutes later is much less valuable than knowing about it within 10 seconds, especially for use cases like banking
Yeah.
or logistics, right? Routing drivers. So I think in some ways, Pinot might be an example of a technology where sometimes the tail does wag the dog, where the existence of a database that can deliver real-time insights can actually reshape how the business operates, right? Because it changes
Right.
what's possible. I think, talking about the architecture of Pinot and some of the decisions that went in, one of the things that when I've talked to technologists and creators like yourself, there's often some contrarian decisions that have to occur in the early days. And just by way of example, because I think they're obviously addressing a different segment of the market. When I talked to Hannes at DuckDB, the creator of DuckDB,
Mm-hmm.
one of his contrarian decisions was we're going to focus on single node architecture.
Mm-hmm.
We're going to focus on scale up, not scale out, which at the
Mm-hmm.
time was very much not in vogue.
Mm-hmm.
And of course, fast forward a decade or more, that decision has been borne out for a certain class of use cases that you can scale up quite a bit. What were some of those contrarian decisions that you felt you were going against the grain when you were thinking about the architecture of Pinot, um, both at its creation, and then I'll ask a second question. What are some decisions that if you could go back, you might have made differently? And
Yeah,
I'll add there, which is I saw today that Kafka announced after many years of service, they said we're finally getting Zookeeper out
absolutely.
of Kafka as a
Yes.
dependency. So those are the two questions. Yeah, contrarian decisions you made that you were happy with, and maybe decisions you made that you would like now maybe to contradict if you could go back in time.
Yeah, no, I think that the first one was definitely there was a huge pushback on building this on a columnar store. I think if you go
Mm-hmm.
back and then look at it, people get scared of like, hey, how are you going to do updates in, how are you going to do appends in columnar store, and how are you going to make sure that you are not compromising on the freshness. I mean, that's kind of when most people resort to like micro batching so that they can actually flush. So that was a big challenge, and most people thought they couldn't do that.
Let me ask, I'm going to follow up a sub question. How have you, because I do know something that Pinot is known for is your support for upserts and
Yes.
updates.
Mm-hmm.
Tell us a little bit about, even though you just decided to go with this columnar architecture, how does Pinot support updates to existing segments?
Yeah, so I mean, again, this took multiple tries for us to actually get this architecture right, especially on the upserts, because again, this is a contradicting thing that we had to go for, which is if you look at most databases that support upsert, they do LSM trees, right?
Mm-hmm.
Which is like they do the merge during write and sorry, during read and not during write. But I
Mm-hmm.
had to make this decision that no, I'm going to resolve that conflict at write and not at read, because
Mm.
I don't want to compromise on my read performance. So I want each partition to be as fast as possible in parallel. Because if you kind of put this additional step in your query that you have to do the merge before you actually start processing that record, then your latency is gone for a toss. You won't be able to
Right.
serve at that millisecond. So for us, we actually resolve that. So we maintain where is the actual row for that particular key, and then we maintain a bitmap within the system to make sure that it gets updated. And the nice part about this is like we now get a change log as well. So we were
Mm-hmm.
not only able to support like what's the latest record, you can actually find like, hey, what
History.
was the history as well. So it was kind of,
Mm.
it came across as a secondary benefit that we didn't anticipate. But that actually became another interesting feature. It's like, hey, what was the value of this record at this time? And you can actually even skip the upsert and then you can look at all the changes for this record as well. So we had to make that huge, big decision on how to solve upserts.
And,
Uh,
and I'll just say, from having obviously played in this space, as much as from a technical perspective, we love the idea of a world that is append only and the past is
mhm.
immutable. The messiness of the real world is such that we are always dealing with late arriving data, data that was maybe even incorrect. So, we,
It's one of the most popular features of Pinot, right?
yes,
And it's scaling like crazy in terms of the number of records that needs to be maintained.
yes.
So I think we are very happy. I mean, again, we did one version that didn't actually work out well, so we had to redesign that. Again, these are all the
Mhm.
fun stuff in distributed systems. While you
Yes.
have the vision, you take the challenge, and you do bunch of mistakes along the way, but we had to spend 1 year and then throw out the entire work and then restart that. But we are glad that we finally got it right.
So other contrarian sort of decisions you felt. So you said first was, yeah, choosing a column store,
Mhm.
columnar, what are some of the other architectural
So
decisions that felt
yeah, so the second
strange?
one was the indexing itself. I think there, while on paper people think that indexing is kind of at a high level, it's good, but most people hesitate. I mean, you talked about DuckDB, right? I mean, they're of like, hey, let's scan very fast, right? And
Mm-hmm.
so I think for me that was a good enough. I mean, it was a good enough solution, right? But then as you scale, for me, I was always thinking about, hey, what will happen as we scale the data? What will
Mm-hmm.
happen as we scale the number of records in this? Is my latency going to be proportional to the number of records that I scan? And
Mm-hmm.
yes, that's going to be the case, because yes, you can try to do all sorts of vectorization, all sorts of compression, everything, but then you're always limited by physics, because
Mm-hmm.
you are getting faster, because not because you're doing something unique, it's because your SSDs are becoming strong, faster, your network is becoming strong. I mean, if you look at anything that is going over the network and then looking at S3 and things like that, there is very little innovation. I mean, there is some innovation in the application layer, but it's majority of them is coming from S3 being able to provide a faster latency, and
I
then the
get it.
networks actually getting improved. But you're not really doing anything cool from your application to actually leverage that even more. So for me, it
Mm-hmm.
was always about, this is something that I got inspired from Kafka, which is really I wanted to look at the cost per query. So when I look at
Mm-hmm.
cost per query, it's not the pure latency, but it's the actual work that is done during that
Yes.
query. So I want
Yes.
and if you look at Pinot actually does the most minimal. If you look at all these databases and then you try to go deep and then say like, hey, what is the actual work that is being done? Pinot does the
Hmm.
least amount of work. And that was the goal that I was actually shooting for, not just to say like, okay, let's throw a bunch of machines and then we will still be able to get the latency because you can have the parallelism. But
Sure.
then what's your total work done? Because that comes and bites you when you had more concurrency. Because you might run
Yes.
just one query and then you might get a better performance. But what if you run hundreds of queries here? So being able to have that latency curve maintained as you add more data, as you add more queries per second, was an in challenge that I took on. While it's most people said like, hey, don't try to solve that problem.
So I guess the theme there being, indexes help StarTree and Pinot work smarter, not harder, right?
Exactly. Yeah,
So,
exactly.
and tell us a little bit about some of those. I mean, again, the eponymous, the name of your company that is, the commercial leader for Pinot is StarTree.
Hmm.
Tell us a little bit about some of those indexing structures in Pinot, and maybe I'll even say more specifically, what are those indexing structures that do not exist in, let's say, other OLAP engines that people might
Hmm.
evaluate, like DuckDB, Starbucks, Druid,
Yeah, most of them.
ClickHouse.
Yeah, most of them use the regular indexes, which is like the inverted index or Bloom filter, and some of them, like ClickHouse, for example, has skip indexes, doesn't even have the row level indexes. Um, we go way beyond that, right? So we have range index, for example. So if you are looking at a performance log and say like, hey, what are the requests that were less than 3 seconds or greater than 3 seconds? You don't want to scan every record, and then even if you're just using min max, that's not. So we have a very amazing range index, right? So we
Hmm.
actually look at the bitmaps and then do some crazy stuff there to figure out like what are the exact rows that actually match. So we don't actually inspect every record to say like which record crosses three. So range index is one. And then we also have within the JSON, we can actually get to the next level in terms of any nested field can actually be indexed as well in terms of geospatial. Like we worked with Uber, and then we actually, if you instead of using lat and long, we actually have the H3 index. So
Yes.
if you search for like 5 mile radius, it should be 5 mile radius. It shouldn't be like some approximate squares around that. That will actually
Hexagons, right?
hexagons.
H3 indexes uses hexagons, right?
Hexagon. So very, very accurate, right? I think that's another. So the thing that we had was we built index as a first class citizen. It was not an
Hmm.
afterthought. I think that's the major difference from when you look at from other databases versus us. So as and when we keep coming up with new indexes, vector index came, it was very easy for us to add because we kind of start with that as a first class. So it's a lot of things are actually designed around that. And last but not the least is also the StarTree index that you mentioned, which is we kind of call it as an index, but it's really a smart, very, very smart
Algorithm,
algorithm in terms of
materialized view. Okay.
materialized view, right? So that's really the concept there. But if you look at most of the materialized view concept, they are dumb. They basically say, okay, these are the dimensions. It basically goes and creates all possible combination. And there's nothing innovative there, right? That was the old world of OLAP cubes, right? Where
Yes.
you would pretty much compute every answer that is possible, and you would
Yes.
put it in a key value store and probably query that upfront. But starter index was really being smart about understanding the data and then creating aggregates only for the things that we think are going to be expensive at runtime. So it's not just based on the workload. So it's a very cool concept, and I generally try to explain this with example of if you look at in ads world or something like that and say like, hey, how many impressions happened in US, you might
Yes.
have an inverted index, but that's going to match 50% of your records because most of your ad impressions might be coming from US. But
Right.
and so the query is going to be slow, right? If you can start counting the revenue of those impressions. But if you ask for something like Kenya, it's going to be fast because not many records match Kenya. So
That
now,
right.
yeah, so now you have this index, but then your query latency is highly variable. If you ask US, it's very bad. If you ask for Kenya, it's very fast. but that's a very tough world to be living in from an experience, from an application point of view.
Having
That
consistency, right?
consistency. So that's kind of where StarTree comes in picture. So now
Okay.
what StarTree index will do is it will automatically compute and aggregate for US, but it will not compute anything for Kenya. So it will.
Ah, so one area, maybe this gets to kind of future thinking. I think there was a paper that the very widely admired Jeff Dean of Google wrote several years back, maybe before the current AI boom, about learned indexes.
Yes. Yep.
And I think, maybe many of us who look at what's been happening in the world of large language models, it's
Mm-hmm.
pretty inspiring to look at what DeepSeek has been able to do in terms of, let's put aside whether they're honest about
Mm-hmm.
where their training data came from,
Mm-hmm.
but just in terms of the amount of information that can be compacted into a large language model that you can actually run on on a single machine. Now a
Yep.
beefy
Mm-hmm.
M4 M3
Mm-hmm.
machine. It feels like there's an opportunity for those of us thinking about the database world to just do a better job
Yep.
with kind of our indexes, right? We think about
Yep.
the nature of again LLMs as these vector embeddings, right? That really compress the world down into much more efficient data structures. What are some of the, and this is a leading question, of course, but
Mm-hmm.
how do you think about what kinds of indexes might be possible in the future for an engine like Pinot to work smarter and not harder? And you
Yep.
mentioned StarTree indexes. Is there a sense where we could start to think about the empirical usage of the database informing what
Yep.
actually gets indexed and how we maintain it on disk, the physical layout?
No, this is a fantastic question. I mean, I'm really happy that you asked this, and I think you should actually be building databases. I can the fact that you're actually thinking along these lines. The reason why I say is this was actually an project that one of our interns did last year for us, and we found like really interesting, very exciting performance improvement. So I mean, without getting into the details, I think the way to think about this is like more of if you were to increment the count of every record that got hit, and then
Hmm.
zoom out, and then you have a heat map of all the things. Now think about all the red ones are your hot bits,
Hmm.
and anything that is not actually accessed frequently. Now, if you feed this to an LLM model and then ask that, hey, these are all the different hits that I'm actually getting. This is now, can you actually tell me what to pre-aggregate, what to not pre-aggregate upfront, right?
Hmm.
And that's kind of what we did, and it's actually fascinating to see those results. So we are working along some of those things, which is, I mean, you mentioned about learned index. Learned index is fantastic, but it's really just more solving about the hash lookup, right? Which is like,
Hmm.
I need to look up this key where what is the probability of, but in OLAP, you can't really just do that. You need to give exact results in terms of the answers. So that's
Right.
and you're scanning multiple rows as well. So
Right.
you're spot on in the sense that if models can actually learn some of these things and say like, hey, this is the query that is coming in, the potential of finding answers in this part of the data is quite high.
Yes.
That can actually reduce a lot. I think the challenge with models is always um, the false positives or the false negatives rather, where it probably points her to a region and there is data in another region as well, and you can't really
Yes.
compromise on that. So that's last part is what is going to be challenging, but it can definitely simplify a lot of things for us. And even if it
Other,
if it can solve like Bloom filter,
right.
it's fine. That's actually still a positive.
Yes. I was going to mention Bloom filters, of
Mhm.
course, where right, just sort of excluding, just knowing where I know for sure my data doesn't exist
Exactly. That
can
might be a fault. That's
drastically reduce the how many segments I scan, right?
yeah.
Well, maybe before I shift to my last set of questions, I guess other things that you are excited about on the roadmap for Pinot, for folks who are using Pinot, considering Pinot, what are some of the other directions that your team and colleagues and the community is looking to take the project in the coming, let's say, the coming year?
Yeah, no, I think one of the things that we focused heavily on, like the user facing, like external facing applications, right? But over the last 2 years, we are seeing huge pull on like all the internal applications as well. Like think about product analytics, like people were using tools like Mixpanel and Amplitude and
Mhm.
other stuff. Now they're doing a lot of funnel analytics on top of it. And I think all of these started with us adding the support for joins, right, which was not there in our previous version. So the joins has become something that was like a weakness for us, has become a huge strength, and we are pretty much like beating every other system out there in terms of join performance because
I'm gonna yeah, drill down on that. Tell us about the architecture. That join sounds like similar to upserts, where certainly
yeah.
not a small feature to implement in a
Correct.
large scale analytics
Yeah,
engine
and
like
then the
Pinot.
same thing as upsert, right? We didn't want to do exactly the same thing as what a Presto or a Trino would be doing, because then
Hmm.
you're just trying to play the same game with like the same strategy as well. So for us, it's again goes back to the first principles of how can we reduce the amount of work done in join, right? Again,
Hmm.
so the two things in joins is like that kills joins performance is like the scan and filtering, and so there is a lot of push down and other stuff, but we can leverage our indexes there. But the second part is the shuffle, right?
Hmm.
So how can we avoid the shuffle? So that's where we leverage a lot of our indexes as well in terms of avoiding the shuffle, and also the all the placement strategies. So we have a lot of ability to do co-location of these different partitions together.
Hmm.
So again, going back to the same thing is like, how can we leverage the indexes that are there in Pinot? So instead of pulling both the left and right and then doing the join, we actually just pull one side and then push down the other side back into the instead of doing the traditional joins. We call that like dynamic filtering kind of a concept. Maybe that's pulls from one side and pushes it, and then you can actually leverage the indexes quite heavily. So our goal is still to be able to solve even the joins in like the second range, sub-second range, so that you can actually
Hmm.
use it for interactive applications. Um,
The uh, of course, which is a huge advantage, again, from the experience that we've had over time, is that especially in analytics, the requirement to actually materialize
yes,
all of the information that you want to make available in an analytics application sometimes can be challenging. And so folks to be able to have I think a more flexible system where labels may change or attributes
yes.
may change. I would say, of course, the joke people will talk about before with, everything is much harder when it's distributed, right? So joins are
Hmm.
easy on
Yes,
single node systems.
exactly. Yeah.
MapReduce is 3 lines of Lisp, right? All
Yes.
of the code for MapReduce is making it distributed,
Yeah.
parallel, robust, frankly,
Hmm.
fast is another angle. I want to I want to just shift a little bit to talking about your journey as a technologist, as an open source creator. I know we've
Hmm.
got a few minutes left here, and one of the things that I heard in an interview you did a couple of years ago was, when you think about the roadmap and you think about what to build next, I think your quote was, and I think I wrote it down here, was you don't need a product manager when you have a community. Uh,
Oh my God, that's going to get me in trouble.
yeah, and not to say product managers are very, very valuable,
Yeah.
but uh, and maybe the answer is not either or, right?
Hmm.
Maybe you don't need as many product managers when
Yeah.
you have a community, but maybe just talk a little bit about that Pinot community, and how it's informed the growth of the project, and really just in your own words what you meant when you said when you gave that quote.
Yeah, I think it's more about understanding your users at the end of the day, right? I think because they see things sometimes that you are, because we always, as founders and creators, we come with our own opinions and mindset and say like, This cannot be done, this shouldn't be done, this is not how the world should be, and things like that. But then when you hear from the users, and then if you keep an open mind, there is so much value that you can actually get from them. So for me, it's like I still spend a lot of time on the Pinot Slack, and then whenever someone asks a question, I get intrigued by their use case and like, hey, how did you think about using Pinot for this? Because I myself wouldn't have thought about it. And then they come up with, oh, you see this use case that there is a blog on this, and then we are actually doing something very similar, but for a different domain. I'm like, wow, that's crazy that how they are actually able to think along those lines. So I think for me, it is just about getting ideas from every part of the world, and from every developer, because generally they are thinking completely different directions than what we would be thinking, and that opens up a lot of possibilities. And that's kind
I,
of how we got here. It was always listening to the community, and we wouldn't have done Upserts if it was not for Uber asking us to say like, hey, this the fare of a ride changes after the ride, and how do we
fix it.
how do we
Right.
fix it? Right? It's just some simple things like that, and then it just sometimes you take it as a challenge and see like, hey, how can you actually solve these things, and then one thing leads to another.
I there's an interview podcast that I heard with that referenced Tim Cook, who is the creator of Intuit, and he had a quote where he said he asked product managers when they were thinking about a product feature, when they went and interviewed customers or their community of users, what surprised them. And if a product manager came back and said nothing surprised us, he would say you didn't actually do the interviews, because in some ways, surprise is
Yeah,
the essence of information, right? It's the
yeah,
unexpected. And we
exactly.
know, and the only way we make progress with our products is when we get an unexpected bit of information from
Hmm.
the users. Otherwise, there's no point in listening to them if everything they say can be compressed away as
Mhm.
expected.
Yeah.
Um,
No, no, I think that's a great point, and it's and just asking the right questions and also being open, right? I think I had made that mistake myself, being very dismissive of like, this person doesn't know what he or she is talking about, but then they come up with like really cool things, and I think just being having that open mind helps a lot.
I think the key element for maybe product managers listening to the community is always separating between what people are asking for
Yes.
versus why they're asking for that.
No, I think that why
Right.
is such a critical piece, and then most people don't get it. It's about the why, because that's something that I am very conscious about as well now. When even if it is customers or if it is users, I don't want them to come up with solutions, because that's not their. I
Right.
really want them to talk more about like, hey, what's the problem that you're trying to solve? Why are you
Yes.
trying? And then we'll figure out. I think there are people who are living and breathing these databases for like
A long
multiple
time.
decades, long time, so they know how to come up with and again, sometimes you get really good answers from, but that's generally rare, because if you don't um, work on this day in and day out, this is so deep, and what feels like a simple thing doesn't really work at scale. But
Right.
that's, I think you hit on the right. It's like asking the why. I think where I think that's the most important part.
I'm gonna end with one broad question before we let you get back to your busy life as the founder and CEO at StarTree. We are in the broader space of data infrastructure.
Hmm.
This is where StarTree is playing, and we've got some behemoths on the landscape. We've got um, Databricks and Snowflake, most
Hmm.
notably. And I think one of the things we've seen in the last few years is this shift towards object storage as
Hmm.
an incredibly disruptive technology,
Hmm.
namely S3 and Amazon, but certainly Cloudflare has their version R2.
Yeah.
For folks that are open source on-prem, Minio, continues to make progress. We saw that Tabular got acquired for $2 billion after a
Hmm.
bidding war between Snowflake and Databricks. What, and I'll be maybe specific, given the rise of data lakes and object storage, right? We saw WarpStream got acquired by Confluent, an
Mhm.
object store backed, streaming system. What, with regard to object stores and Iceberg, what is StarTree's, how do you look at this trend of embracing object stores? I know we talk about low latency and
Yep.
freshness. Yeah, how does the Pinot community, the project, and StarTree as a commercial business, how are you thinking about these macro trends of everyone kind of, and really maybe the convergence of the data
Yep.
warehouse uh, with regard to Snowflake and kind of data platforms backed by, Delta Lake or Iceberg on the
Mhm.
Databricks side?
No, I think this is a great time to be in when advancements like these are happening, right? And especially on the object store part, I think S3 is definitely setting some of the standards there, right? I mean, I can see that there is still a huge gap from S3 to some of these other file systems as well. But being able to work at a low level API than just at an object, right? Because we are still trying to push the boundaries of analytics. I think Databricks and Snowflake are working towards a slightly different objective in terms of just enabling anyone to be able to query data on object store. But if you get down, I feel very angry sometimes in terms of the number of computes that get wasted in terms of reading data from these object store. But
Mm-hmm.
that's a lot of these limitations are actually because of either how object stores are built, because you can't append, you can't upsert on those things.
You can't, although recently S3 did offer, they do have support for appends on S3 objects.
Yes, I think it again comes down to like in terms of the cost on what they're
Mm-hmm.
actually what is the cost under the hood. But those are all great enhancements, right? In terms of,
Mm-hmm.
but if you now go back and then look at the formats, are they capitalizing on that?
Mm-hmm.
Right, so they're
Mm-hmm.
not like really leveraging the concept. Like if you look at icebergs and Hoodie and Delta Lake, all these formats, they're rewriting the files. Right, it's
Mm.
just there's so much of, I mean, it makes sense, but me coming from like where we are trying to optimize every microsecond and every nanosecond, and you see on the other side the amount of CPU that gets wasted in terms of fetching all this data and then filtering that. I think there is still a long way to go in terms of
Yes.
how object store can actually become mainstream, and that's some of the things that we are doing in StarTree. So
Mm-hmm.
we now have a tiered storage version of Pinot where we are actually able to provide sub-second latency on the data in S3, but not going through the regular APIs. We are not just trying
Mm.
to do a lazy load of like, okay, let's fetch
All the
everything and
segments
then
in.
and that's so we actually go to the byte level, and because of indexes again. So what we do is we
Mm.
use the index, we know exactly the byte range that needs to be queried, and then we just fetch only those byte ranges because you're limited by the throughput on S3,
The
right? So you
network.
can do, let's say if it is 1 Gbps per second, you don't want to pull in trash and then use up all your bandwidth to actually get all the data that you probably don't need for your query and then
Yes.
waste all the bandwidth. So that's kind of the enhancements that obviously we are doing. And that's what I'm really proud of in terms of how we have architected, because it was actually not that hard for us to go from something that was relying on local file system
Mm-hmm.
to something like S3. So we were able to
Right.
actually abstract out the buffer concept and then be able to directly work on S3 without having to pull the data locally. And we are
So,
doing a lot of pipelining and other concepts as well. So good.
so many of these architectural innovations that started with, how do we make Pinot smarter in terms of how we access data, that's coupled in a coupled architecture are now
Mhm.
paying dividends in terms of how you access data
Exactly.
on object stores and in an efficient way versus right pulling gigs and gigs across the
Exactly.
network,
Right. Yeah.
the
And again,
network.
a lot of these decisions, I mean, I think there is a little bit of craftsmanship, but there is also a little bit of luck, right? I think we never anticipated some of these things would actually pay us dividends like this. Because if you look at the segment format, we separated out the index from the forward index from like all these are different entities. So that allowed us to actually leverage the enhancements that happen in outside of Pinot as well, like whatever is happening in S3 and other systems. So now we can control of, we can actually keep just the index local at a
Hmm.
column level, at a table level, at a time level. Like we have like the full flexibility and say like only this data will be StarTree index will be local, everything else will be remote. So we get all these flexibilities, and you can kind of pick and choose and have the right trade-off in terms of latency and cost, which was a very important thing for us, because most people come and say like, hey, Pinot is too fast. I don't want this. I don't need so much
Ah,
speed. It's okay for
right.
me to be second, but can I just work on tiered storage?
Right. Can they take advantage of some of the efficiency that Pinot's
Yes,
indexing structures allow, but not necessarily need to have maybe the sort of
local
local
assist.
storage,
Yes,
right?
exactly. Yeah,
Well, I really enjoyed this conversation, Kishore. I appreciate taking time to chat with me and hopefully with some of the engineers and developers around the globe that will tune into this interview. I look forward to doing some work together. I know we're colleagues in this data
yes,
ecosystem, so really have enjoyed getting to know you and the StarTree team over the last year. And thank you for joining us. Thank you for sharing your wisdom. And I look forward to more in the future from you.
absolutely, Mike. It was a pleasure being on the show, and I think this was one of the shows where I could go deep. So thank you for bringing out the engineer in me. But this is I thoroughly enjoyed it. So that was thanks again for having me here.